Imagine you're sailing on a vessel designed to reduce CO2 emissions by up to 25% and completely eliminate other pollutants like sulphur and nitrogen oxide. Believe it or not, the solution may lie in this icy pool in northern Germany. Ambient temperature is minus 10 degrees centigrade. Water here stands at a chilly minus 0.8 degrees centigrade. It's early morning and researchers here are on an icy mission. They want this test pool to mirror the Arctic environment. Salty water here is at freezing point. Scientists first measure the thickness of the forming ice sheet.
In every test, we perform some 200 measurements. We measure the thickness of the ice sheet in 200 different parts of the pool. This is because the ice is not uniformly compacted everywhere. It's the same situation we find in the Arctic, so we need to try to obtain a good average with tests that are sufficiently long, meaning our data and measurements are accurate enough.
With the test tank ready, naval and mechanical engineers take over. They use this model to assess how a newly designed, larger ship propeller would perform in extreme conditions.
At the front we measure the resistance of the model. Here at the back we measure the rotating speed of the propeller, also the thrust and the torque on the propeller, and we measure the side forces and the bending moments.
The experiment is part of a European research project aimed at developing more efficient vessels which cause less pollution. And researchers say the model propeller tested here is a promising new tool.
We have learned indeed that it is a very nice concept and which has a lot of potential, the fuel saving. And yes, this is a kind of design concept study. So when it is being built, there probably will be some small changes for practical reasons or because the ship owner wants it. So maybe you lose a little bit. But normally this is a step to a real new generation of ships.
A new generation of ships that is also being shaped from these Dutch shipyards. Engineers have designed a tug here with a reverse stern drive system and a new hull shape that allows more manoeuvrability at high speeds in overcrowded ports.
Bigger vessels are entering our ports, but the tugboats have to deliver more power and have less space to maneuver in. So this hull shape will enable us to be very maneuverable.
The next step is to build tugs that run on compressed natural gas. Scientists see this green alternative as offering a competitive edge in a challenging market.
If you want to be competitive, you need to save money on, for example, fuel. But also emission in a lot of ports is a big issue. Ferries, cruising industry, dredging. So they are developing hybrid systems to follow that market. We would like to be also part of that.
Researchers hope some of their innovations can become a market reality in less than 5 years.